You're in Jerusalem. It's the year 68 CE, and Roman legions are camped outside the walls. Your neighbors are packing what they can carry because in 2 years this city will burn and everyone who survives will scatter. There's no map for where you're going. There's no language waiting for you that you already speak. There's no guarantee anyone in your family will end up on the same continent. And somewhere in that scattering, one of your ancestors walked west into Europe, another walked south into North Africa, another stayed in the Middle East entirely. Different roads, different centuries, different languages picked up along the way. This is the story of what happened to those 3 roads 2,000 years later, when scientists finally had the tools to check whether they were ever really the same family at all. Not a religious argument. Not an identity politics debate. Not a ranking of who counts as what. Just DNA and the very unglamorous question of whether 2,000 years and 4 continents is enough to erase a shared ancestry or not. Here's the thing worth sitting with before the results. By the year 2000, Jewish communities existed on every inhabited continent, speaking Yiddish in Poland, Ladino in Spain and the Ottoman Empire, Judeo-Arabic in Iraq and Yemen, Amharic in Ethiopia, Malayalam in southern India. On paper, these looked like completely different peoples who happened to share a religion, separated by more centuries than most nations have even existed. So here's the real question. Does 2,000 years of separate history, separate languages, and separate neighbors erase what's in your genes, or does DNA keep a record that culture can't touch? In 2010, geneticist Doron Behar and his team, publishing in Nature, ran a genome-wide comparison across the major Jewish diaspora groups: Ashkenazi, Sephardi, Iraqi, Iranian, Syrian, and more. A separate team led by Gil Atzmon published matching results the same year in the American Journal of Human Genetics. Both found the same thing. Despite centuries apart, these communities still clustered together genetically, more closely than any of them clustered with their host nations, and all of them traced back to the same point of origin, the ancient Levant. The clearest single piece of evidence for this came from an unlikely place: the Jewish priesthood. In 1997, geneticists Karl Skoretsky and Michael Hammer tested the Y-chromosomes of men who, by family tradition, believed themselves descended from the biblical priestly line, the Cohanim. Men from Ashkenazi communities in Europe and Sephardi communities in the Middle East, who had not seen each other's ancestors in over 1,000 years, shared a distinctive genetic marker at rates no coincidence could explain. Here's the honest part of the story, though: it got more complicated, not less. A follow-up study in 2009, again led by Hammer's team, found the priesthood actually carried multiple distinct lineages, not one single unbroken line. The original finding wasn't wrong, it was just simpler than the real, messier history turned out to be. That's how good science usually goes. The maternal side tells its own strange story. In 2006, Behar's team traced Ashkenazi mitochondrial DNA. The line passed only from mother to daughter, and found that roughly 40% of today's Ashkenazi Jewish population descends from just 4 women, likely of Middle Eastern origin, who lived somewhere in Europe around 1,300 years ago. Not 4 legendary figures. 4 actual women whose descendants happen to number in the millions today. It isn't a clean, simple story either. A 2015 study found a genuine genetic contribution into Ashkenazi communities from populations further east, arriving along Silk Road trade routes, centuries of contact and travel leaving their own small mark on the bloodline. And here's a detail that surprises people the most. Those same genetic studies find that Jewish populations are closely related to their ancient Levantine neighbors too: Palestinians, Druze, and Bedouin communities, all tracing back to the same regional ancestral population thousands of years before any of the modern political map existed. This isn't just academic trivia. The same founder effect that produced those four mothers also concentrated certain disease genes. Conditions like Tay-Sachs and specific BRCA mutations show up at higher rates in Ashkenazi populations today for the exact same genetic reason. A small founding population expanding rapidly, carrying whatever genes it started with, good and bad, into millions of descendants. Here's why that mechanism matters beyond one population. It's the exact same math that explains elevated genetic conditions in Finland, in Iceland, in any isolated founding population anywhere on Earth. A small starting group plus centuries of marrying within the community equals genes, useful and harmful alike, showing up more often down the line. It isn't unique to one people, it's just unusually well documented in this one. Here's the uncomfortable part underneath all of it. This diaspora didn't scatter by choice. It was expulsions, forced conversions, pogroms, and in the 20th century an attempted extermination that nearly succeeded at erasing entire branches of this family tree permanently. The DNA data isn't just a curiosity, it's a record of survival against a couple thousand years of people actively trying to make sure that record didn't survive. So back to that rooftop in Jerusalem, 68 CE, watching the roads scatter in every direction. 2,000 years, 4 continents, a dozen languages, and none of it was enough. The DNA still remembers exactly where it started.